Have you ever watched two planes cross the same patch of sky, same altitude, same direction, minutes apart, and one leaves a white line that stretches for miles, while the other leaves nothing? Same sky, same conditions, different result. Most people assume it's the type of plane, or the chemicals, or how fast it's going. It's none of those things. The difference is invisible. You can't see it from the ground, but it determines whether that white line appears or vanishes within seconds. Stick around. By the end of this, you'll know exactly what those white lines are made of, why they only form sometimes, and why they might matter more than you think. For most of human history, flight left no visible trace. But as planes climbed higher the 1930s, something unexpected happened. Sky began keeping a record. The Earth's atmosphere is layered by temperature and pressure. For decades, aircraft stayed low, where the air is thick and warm. Their engine exhaust just dispersed. No visible trail. But engineers knew that flying higher meant less drag, which meant better efficiency. By the late 1930s, planes could reach altitudes above 30,000 feet. That's when pilots started noticing something strange. At these heights, the exhaust didn't vanish. It formed clouds, long, narrow clouds that stretched behind the aircraft. So here's what's actually happening up there. Jet engines burn fuel. That creates water. At 35,000 feet, it's so cold, often below -40 degrees, that water instantly freezes. That's the line you're seeing. Millions of ice crystals suspended in the air. The exhaust also contains tiny soot particles, and those particles give the water something to freeze around. Within seconds of leaving the engine, the hot exhaust hits air so cold, it forces an immediate transformation. Water vapor becomes ice. This is why contrails are white. Ice crystals scatter light in all directions, reflecting sunlight back to your eyes. It's the same process that makes your breath visible on a winter morning, just stretched across miles of sky. But here's the thing. Not every plane leaves a contrail. Two aircraft can pass through the same patch of sky minutes apart. One leaves a long white line. The other leaves nothing. The difference comes down to humidity. Contrails need three things: cold air, high humidity, and engine exhaust. If the surrounding air is already saturated with moisture, the ice crystals stick around. The contrail persists, sometimes for hours. Wind stretches it across vast distances. Sometimes it grows so wide it starts to look like a natural cloud. But if the air is dry, the ice crystals evaporate almost immediately. The line forms briefly and then erases itself. That's why contrails are unpredictable. Now here's where it gets more complicated. For decades, contrails were treated as harmless, just a visual curiosity. But in the 1990s, researchers started measuring how they interact with radiation. Ice crystals reflect some sunlight back into space, which cools the Earth. But they also trap heat escaping from the planet, which warms the atmosphere. On average, contrails contribute to warming. The estimates are striking. Contrails may contribute as much to climate forcing as all the carbon dioxide emissions from aviation combined. The white lines in the sky aren't just evidence of flight. They're actively changing the atmosphere. Once that became clear, engineers started asking whether contrails could be avoided. The simplest solution is changing altitude. Since contrails only form under specific conditions, flying a few thousand feet higher or lower can move a plane out of the contrail zone entirely. In 2021, American Airlines and Google ran a trial using satellite data to predict where contrails would form. Pilots adjusted their routes accordingly. Contrail formation dropped by more than 50%. The fuel penalty was modest, less than 2% on most flights. Alternative fuels also help. Synthetic jet fuels produce fewer soot particles, which means fewer ice crystals can form. Early studies suggest these fuels can reduce contrails by up to 70%. The challenge is scale and cost, but the technology exists. So the next time you look up and see a white line stretched across the sky, you'll know what it really is. Not chemicals. Not a conspiracy. Just ice. Millions of microscopic crystals form the instant hot exhaust met cold air. Picture a jet engine at 500 degrees, spitting water into air at -40. Instant ice. That's the line you're seeing.